Welcome to this explainer. Today, we're going to completely rewire how you look at legal documents. We're unpacking the first 4 lessons of the C-LEAD curriculum, which stands for Computational Legalese. Now, if you're a law student or a legal practitioner, you know you already have absolutely world-class logic skills. But you might just be missing the programming grammar, the syntax, and those system design principles required to actually apply that logic digitally. So today, we're going to bridge that gap.
So what actually happens when paper contracts come alive? I mean, think about it. For centuries, the legal profession has relied on written, natural language to express agreements, right? Just static documents sitting in a filing cabinet somewhere, just waiting for a human to pull them out and interpret them. But today, we're moving away from that world of dead, static paper and stepping directly into the incredibly dynamic realm of legal engineering. We are translating paper-based legal obligations into active executing code. I really want to let the weight of that sink in for a second. It's a massive paradigm shift from dead text to living systems.
Here's our roadmap for today. Number 1, the meaning of performance. Number 2, software runtimes explained. Number 3, the composer metaphor. And finally, number 4, lowering social transaction costs. Let's just jump right in.
Starting with Section 1, the meaning of performance, fulfilling obligations on paper.
Okay, so in the familiar territory of traditional law, a performance is pretty straightforward. It's simply a human party fulfilling their contractual duties exactly as they were written down on paper. When lawyers draft a contract, they're essentially writing out exactly what performances the party should fulfill out there in the real world. It's literally an instruction manual for human behavior. But historically, ensuring that performance actually happens, well, that requires a lot of manual oversight. Every single time an obligation is met, a human has to verify it, they have to record it, maybe chase down a payment, and sometimes even argue over the whole thing in court. It's just a very slow, high-friction process.
Moving along to Section 2, Software Runtimes Explained, the execution of instructions. Now, in the tech world, a software runtime is the active, dynamic execution of code. Basically, it's the computer autonomously fulfilling its programmed performance from start to finish. I want to pause right here for a second, because this conceptual link, it's the core insight of this entire explainer. A contract outlines a performance, and a runtime literally is a performance. Recognizing that law and computer science are actually talking about the exact same fundamental concept is absolutely key to getting into this mechanization mindset.
Just look at the incredible contrast here. In traditional law, you read a static document sequentially, right? Left to right, from the top of the page down to the bottom. But to really engineer law, you have to shift your brain toward more of a calculus mindset. Because in code, an active assignment executes from right to left. Imagine assigning a variable in a program. The computer figures out all the math on the right side of the equals sign first, and then it pushes that final solved result into the container on the left. You aren't just looking at flat text anymore. You're looking at an active machine lever that calculates and executes actions directly on a distributed database.
You know, you might not realize this, but our whole digital world was actually architected by pioneers who translated traditional legal drafting directly into information technology. It is truly mind-blowing. Take Charles Goldfarb, often called the grandfather of the internet. He created markup language, which of course became the foundation for HTML, by directly digitizing traditional legal red-line drafting techniques. That single legal engineering translation helped birth the entire multi-trillion-dollar internet economy. And decades later, Nick Szabo designed smart contracts by taking the fundamental legal requirement of consideration and literally hard-coding it into programming language. By injecting that legal concept, he created the exact incentives needed for decentralized network validators, which is what gave us the distributed databases we all use today.
Which brings us to Section 3, the composer metaphor, designing before play.
To really grasp this new dynamic without getting completely bogged down in technical intimidation, I like to think of a musical composer. A composer meticulously orchestrates verses and looping choruses way before the concert ever begins. And a legal engineer operates the exact same way. You design the contract's logic before ever hitting play to watch the software runtime execute. In traditional law, repetition is almost never made explicit. A lawyer might use a phrase like "for each," but they don't naturally think in programmable, automated loops. A composer, on the other hand, knows exactly how many times a chorus is going to repeat. In legal engineering, we map those musical loops directly to computer science for loops. You design the entire stage performance, you press play, and the runtime just executes the logic autonomously over and over again.
And because we're engineering law like a software system now, we can start thinking modularly. Instead of a giant, intimidating stack of paper on a desk, imagine an intricate, glowing flowchart of dependencies, like digital gears turning one another. This is known as contract chaining. By engineering law in this modular way, if a prerequisite contract or a payment breaks, the entire downstream permission chain breaks automatically. If you modify a single boilerplate indemnity clause somewhere in the system, that one change can instantly cascade down to update every downstream agreement that relies on it. It completely transforms abstract, isolated legal relationships into a highly organized, instantly reactive structure.
All right, final section, number 4. Lowering social transaction costs, the macro impact.
So why go through all this effort, right? Why turn paper into code? Well, because we are rapidly evolving from the slow, high-friction horse and buggy days of traditional analog lawyering and moving directly into the Waymo era of autonomous, self-executing systems. Just as mechanizing transport allowed humanity to move faster than the speed of a horse and totally unlocked modern global trade, mechanizing the law is going to fundamentally reshape our entire economy. It is literally an upgrade to the operating system of human commerce.
Translating paper obligations into active code just obliterates massive amounts of human friction. In traditional law, vagueness and ambiguity are sometimes, considered a feature. It gives you wiggle room. But in code, a single missing semicolon breaks the whole system. Computers demand strict Boolean logic, meaning absolute true or false conditions. There is no maybe. By mapping contracts into this nested deterministic logic, we completely eliminate manual execution delays. When the runtime executes, the performance is mathematically guaranteed. This hyperspeed, deterministic execution drastically lowers societal transaction costs, and it allows markets to operate at a scale and speed that paper contracts simply could never, ever support.
And this isn't just some abstract theory we're kicking around. This is about your future. The macroevolution of the legal profession is splitting right now into two very distinct paths. On one path, you've got developers who will start acting as specialized legal authorities, actually very similar to how highly technical patent agents operate today. And on the other path, traditional legal practitioners are going to naturally adopt programming syntax. Why? Because their daily deliverables are no longer just static PDFs sent over an email. They are compiled, self-executing software dependencies running on distributed global networks. As we shift from static paper documents into dynamic software runtimes, the very mechanics of our society are being fundamentally rewritten. So I'm going to leave you with this final thought to kind of chew on as you navigate your career. Are you going to just sit back and watch the runtime execute like a passenger? Or are you going to be the engineer designing the code? Thank you so much for watching this explainer, and keep learning.